So, first topic for today's theoretical session is called open source software. And in official curriculum there is no such mention, but I think this is very important aspect of configuration management and dependability of a software. And agenda will be that I will tell what open source software is, how to use it, how to produce it, how it's related with so-called term intellectual property, which is not actually a term, it is demagogical slogan. And then a little bit about most common open source licenses. So, hopefully you remember from previous time when I showed that picture about software dependability. This one. And this is like graphical illustration of how software is built, if it's not very trivial and simple. And how sometimes it depends on some very fragile and unexpected things. And if you build such complicated and fragile systems on top of closed source software, usually you don't even know what this particular brick is. And when something breaks in this place, it is very hard and unexpected surprise to you. For open source software, at least in theory, you can know what this brick is, and that is a good thing. Of course, it doesn't guarantee that you will know where this particular breaking point is, but possibility is that you can know at least in theory is very good. And in simple terms, if you look on old school analogies, open source development to closed source development is what alchemy is to modern chemistry. So alchemy comes from Arabic word where every particular word starts with al, which is predicate for many nouns. But at that time, knowledge was guarded as crown jewels and didn't spread through the world quickly enough. And many hundreds of years passed without much of improvements in terms of chemistry and understanding of chemical reactions. But when different approach was used about publishing this information and spreading knowledge, then of course modern technocratic evolution started with all the advantages in modern chemistry. And similarly today in software development we are somewhere in the middle between this alchemy approach, guarding everything in secret, and open source approach or chemistry approach when you start sharing your knowledge and you improve on already known and built things. And here is one illustration of costs of technology, and cost of course is a proxy indicator but very good in terms of summation or aggregation of these things. Particular technology like 3D printers, like 20 years ago, were quite guarded trade secrets and not patented, but trade secret technologies, etc. 3D printing was only for rich and few. But when this technology switched from this guarded, patented closed source approach to open source approach, another jump in terms of availability and costs happened, because innovations and simplifications and all other things become much quicker. And similarly, of course, it happens to software and information services in general. And if we look on terms and definitions, then first term used for such open approach was called free software. It was introduced by Richard Stallman, who was very frustrated first with his closed source printer drivers for Unix-like system, and he decided to write his own printer drivers, and he couldn't find documentation and source code for used operating system. He decided to write entire operating system from new, called it GNU, as GNU is not Unix, and so that revolution started there. And of course, because in English free may mean two different things, like free as in beer and free as in speech, he always had to explain that this is about freedom, not about cheapness. And because of that, later he rebranded this free software to either Libre or to Libre software to stress this liberty and freedom, not cheapness of a software. Because even open source or this free Libre software may be expensive. And of course, other thing he fought for was that it is moral obligation of producers that because of these freedoms, they have to ship software with all these freedoms, open source of software, etc. And of course, most of actual producers didn't share his moral ideas. But later, around year 1995-2000, Eric Raymond wrote his famous essay Cathedral and Bazaar, and he introduced the term open source. Actually, it was introduced in some brainstorming about development of Mozilla browser at that time, and openness was better term than freeness, and at that time many commercial software vendors like IBM, SAP, and other large software companies joined this approach. Later, IBM bought a company called Red Hat, who was one of providers of Linux-based operating system called Red Hat Linux. And then open source, of course, now is much more popular term than free Libre software, and sometimes it's abbreviated as FLOSS, coming from free Libre open source software. So I told you about history already, and also as a byproduct of this history is that there are two foundations which are fighting for user freedoms, mostly user freedoms, not developer freedoms. One is founded by Richard Stallman called Free Software Foundation, or FSF, and another is Open Source Initiative, or OSI. And OSI was founded by Bruce Perens and Eric Stephen Raymond. And Richard Stallman declared 4 software freedoms, which he usually numbers starting with 0. Freedom number 0 is that you have freedom to inspect or view source code of used software. You have freedom to use in any way, including what could be considered illegal usage for different kind of end-user license agreements for closed source software, freedom to modify your copy of source code, and freedom to distribute original or modified version as well. I will tell you later that there are also some obligations, but these obligations come for developers and distributors, not for users. And OSI, which came later, made it a little bit more detailed review. So they counted up to 10 different points, but they overlap. And they name it free redistribution, or this means about free copying of code, availability of source code, allowed to make derivative works or derived works, integrity of author source code, it's about authorship and original copyrights, no discrimination against persons or groups, about the technologies or usages, distributed together with license, must not be specific to a product, software and to technology. And if some particular license, which I will tell you later, conforms to these 4 or 5 standards of these 2 foundations, then they can assign their, let's say, badge of quality of this license, that it is considered like open source or free libre software license. And which are prominent open source software? The most prominent is Linux kernel, which is important part of operating system, and if you have worked with Linux kernel, you know that it is about device drivers mostly, but particularly for Linux, how their API are made in difference with other operating systems, particularly Linux kernel, also includes low-level things like virtual memory management, file system management, network management, a little bit of graphic management as well. So file system, of course, is not part of device drivers, but it is still part of Linux kernel. Then there are original Unix operating systems, and open source part of it is different forks of BSD operating system. And today these are called OpenBSD, NetBSD, FreeBSD, GNU utilities. So Richard Stallman started to write entire operating system with all these utilities. Later, most of free operating systems based their functionality on Linux kernel, but they still use all these utilities, which you mostly run in command line, coming from this GNU operating system. And if you install it as a separate package, like on closed source BSD Unix like MacOS system, then this is something like brew install GNU-coreutils, if I remember correctly. Then x.org graphical interface as a server and part of client for Windows managers for graphical interface of Linux-based system, LibreOffice Office Suite, Chromium and Firefox web browser, and Google Chrome is Chromium with closed source plugins and parts on top of that. Then different programming languages, probably most prominent one is Java, but also Perl, Python, PHP, LaTeX, and different kind of services. And now, why to use open source software? First, because you are relying on shoulders of giants who developed this open source software, and because you have all these freedoms to use software in any way you like. And besides that, you also have easier customability, easier ways to improve something and redistribute. You don't need to count how many licenses you have. I have read some articles that even open source licenses should be counted, but if you are curious about this, I can point you to a link. It is just stupidity and bureaucracy. So you don't need to count open source licenses or installations of software. You can run in different kind of platforms because it's easy ported to different platforms. You can see everything, and of course you can freely use it without paying any royalties. And this is quite old study which shows how different kind of software users consider benefits of open source software, and of course most important one is price. This is not exclusive percentage, because you see 80%, 57%, it means as a multiple choices together. Source code access, community review, etc. And here is similarly for closed source advantages. The most important one is that you always have somebody to blame. Sometimes it's very important if your business case is to say that you are always right and somebody else is wrong, like your service providers or whatever. So, similarly as in construction industry in Latvia, general contractor is never fault of general contractor, it's always fault of its subcontractors. And it of course may be similar in IT sector as well. But for example, about automated updates, and I disagree with this, because I think automated updates are actually better in open source software, particularly for operating systems like Linux-based systems and Microsoft Windows. I don't know about iOS. And here is another use case. Here is list of provided virtual instances which are comparable in Amazon Web Services virtual servers, what means EC2 and Enterprise Cloud version 2, I think. And here are costs for particular amount of virtual memory and virtual CPUs. And if you compare these numbers here, what rate you have for particular CPU and memory, and check what do they cost to you, you can see that depending on some configurations, almost always these virtual instances running on Microsoft Windows are a little bit more costly. Why? Because Windows operating system is closed source system and it is just harder to manage. It is less efficient and harder to manage. So that's first part. If you are not insane, you try to use as much open source software as you can, because sometimes if you started with wrong education, you need to learn yourself and learn new things, like if you have used Adobe Photoshop all the time, then GIMP may be very strange to you, but if you started using GIMP as a first editor, then I don't think that GIMP is anyway worse than Photoshop in any place. And other thing is that what is currently mostly happening is that everybody who is not insane or corrupt or just lazy and crazy is using open source software, but it doesn't mean that they produce open source software. So open source software comes in, but closed source software comes out. And that is de facto standard for today. I hope it will be changed. But why should you also provide open source software by yourself? So not only open source comes into your organization, but it also comes out of your organization. And so this is about development, which also has some strings attached and some obligations in difference with simple usage. First is that you can collaborate much easier, and if you have many collaborators, then redundancy and robustness of your project is much more stable to different kind of changes and crises. And open source software is always reviewed a little bit better than closed source software. Of course, it's not ideal. There are always some bugs hiding somewhere in code, but in general it is better. And you just have better participants in your project with better motivation, and also evolution of software is probably more business oriented and better than closed source. And why it happens in such ways that many of projects, open source projects, starts with solving your own problem, but then authors of the software see that actually what they have solved for themselves may be useful for somebody else, and then they provide source code for everybody else, and then they start building up more and more complicated solutions on top of that. And because of that, you always have more active community, because everybody who is user, at least in theory, may be contributor. And you also get better feedback, because you can better communicate with users and developers, because you have less secrets and guards what you need to guard about. And also, efficiency always is better if you can rearrange and restructure communication, and every communication which is less formal can adapt different kind of changes more easy than more guarded and managed discussion. And many of closed source projects also use lessons learned from open source development, so they try to engage with their users and entire community with discussion forums, emails, and other means of communication. But you always get better result if basis and foundation of this project is actually open source software. And main difference between closed source software and open source software is that you can gradually involve your users as your contributors or maintainers. Here, rule of 90-10 applies. Approximately 90% of your community will be just users, which will use this software and will not give anything back. Then 10% of these may be contributors who at least give some feedback, register some error reports, and then maybe 10% of these may be actual maintainers who maintain this project. And of course it may be different for other communities, like 99%, 1% and 0.1%, but it decays exponentially. That's what is important. But if it's closed source software, you have only small group of maintainers and only users, and you do not have this middle level here about useful contributors who may give you different kind of information, insights back without actually writing source code. And so biggest difference between closed source approach and open source approach is that in open source approach you are ready to lose some control, but you get some other benefits back. And in some projects which are extremely open, like Linux kernel development, which is one of biggest software development projects in the world, important part is that even though in these maintainers, most of these people are paid developers from different companies, but their approach how do they work is still like best effort and informal. And so difference is how you assign work, how you change your software, and how you test and bug. And one of things for Linux Torvalds was about Linux kernel that if it compiles, it's great. If it boots up, it's perfect. So they move much faster, maybe not similarly as Facebook, that they move fast and break things, but they move fast and test a lot. And in closed source approach, usually control comes from management, from top level, and goes down, like push approach. They assign work to actual employees and developers, and if nothing is pushed again, then if developers have free time, and if they are good developers, they just spend their time on some open source projects, and their managers even don't know about this. But better approach is that everybody who is ready to take new task pull this task, and because they care about this particular issue, they want to learn things, and in general it gets better quality. And you will see that here some blurry line is that particularly about push approach from command and control from center to top down, to pull approach, actually here it overlaps, because even if you work on closed source projects like Scrum projects, still work in this open source development approach, even though final delivery is just binary code. And in general, good thing about open source is that it is mostly cheaper for everybody and much easier to port on many different platforms. If you need to support different kind of mobile devices, different kind of computers, etc., then relying on open source software is much easier to you. And my limitation is that there still need some structure, and there still are some maintainers and some contributors who are more equal than other, because without any of internal power structure, this project probably will not move forward in some coherent direction. So there are still some with more rights than others who decide where to move and how to do this. But so you don't mix anarchy with open source development. Even in open source development there is some hierarchy and some structure how to do these things. And now a little bit about other related terms and how closed source approach was introduced. An idea here is that you have to be paid for so-called intellectual property. And what intellectual property is? First, it is demagogical misnomer, because mostly when you talk about so-called intellectual property, you talk about rights. And where is the difference? Property exists without you. Like house is immovable property, car is movable property, and land is immovable property. So it can exchange its owners by buying, selling this property. Rights belongs to particular person. Unfortunately, some rights belong to organization, like a legal person, not physical person. And in general, you are not allowed to buy or sell your rights. If you buy or sell your rights to drive car, your rights to vote, if you sell your rights of freedom of speech, then you are usually doing something very illegal. Unfortunately, when talk is about rights regarding to knowledge and regarding to information, somehow they made excuses in legislation that these rights can be bought and sold. But if you are more specific, so-called intellectual property is mostly copyrights. See, rights here, not copy properties, patents, trademarks and trade secrets. And copyright is very old law. It was introduced when first printed books were invented. An idea here was to get some control how particular books are distributed. Initially, they created law about who is allowed to copy, and at least here this term is proper because right is about copies, not about authorship. In Latvian it is wrongly called autortiesības, which actually should be kopēšanas tiesības. Why? Because how it works, usually author just sells his rights about controlling copies of book to publisher, and at least here it's called properly. First it is right, not copy property, and it's about copies. And so what it actually guarantees is that you have limited monopoly over some particular book originally, that nobody else can make copies of this book. Unfortunately, later it was extended not only to books, but other works like paintings and music and then software. And unfortunately, because of lobbyism from like Warner Music Group and Hollywood, this monopoly was extended from 35 years from publishing till to 75 years till of death of author. But in general it says that only owner of these copyrights is allowed to make copies of the work. How it's applied to the software? It's applied to software with patch, because for copyright work to work properly for closed source software, you have to confirm so-called end-user license agreements, which makes a wrapper around copyright law that it is applicable to software. And if you somehow get closed source software without confirming these end-users license agreements, then actually you, from legal perspective, you are free to use this software, because this ancient copyright law cannot be applied to copies of software without this wrapper and without this intermediate layer. So, about copies, first item is original, everything else is a copy. And particularly for software, first compiled version is original and any other copy is a copy, even though you copy it from hard disk to random access memory. And that's one of the problems for software, how they need to wrap it with end-user license agreements, because otherwise you can't even run this software, because you can't create legally copy from hard disk to random access memory. And then there are different copies, like derivative works when you do some small changes, collective works when you compile many copies together, or joint works. And particularly of software, as I told you, you copy all the time just to execute it, and without end-user license agreements, if you try to apply copyright law as is on software, you can't even ship it on CD or download from internet, and you can't even run it. But if you write this properly, then you somehow can manage it, that you can use it in some ways legally and in some ways illegally. So, what are patents? Patents are a little bit different. They also give monopoly to limited amount of time, but it is immediately published. So, if you patent something, then everybody who reuses your patent have to pay you some royalty. In difference with copyrights, because it's not abused by music and movie industry, this monopoly is still 30 or 35 years after filing this patent, and particularly for MP3 and GPG formats, patents for these data formats ended up a few years ago. So, and because of that, these are not so abused. You still need to be careful about open source license, because open source license may, or open source software may contain something patented inside it, and some of licenses don't care about patents, and therefore sometimes if you are using some open source software which uses like patents inside it, like few years ago MP3 format or GPG format, then patent holder may sue you because you are using their patent illegally. But newer software licenses actually also tells about this, that you are not obligated to pay royalties for patents, and so mostly this is solved problem now, because there are now many of important patents in open source software which still may make different kind of difficulties. And that's, for example, why PNG format was introduced for images and other data formats like FLAC instead of MP3, etc. So that's about patents. And trademarks. Trademarks are just badge of a particular item, and particularly for open source licenses, that usually if you do some serious modifications of open source software, you are not allowed to redistribute this software with the same original name of the project. Like if you modify a Linux kernel quite a lot, you are not allowed to call it Linux kernel anymore. If you modify Firefox browser a lot, you are not allowed to call it Firefox anymore, etc. And now about open source licenses. So open source license is legal term, document which describes what you are allowed to do and what you are not allowed to do. Important thing is that most of open source licenses rely on ancient copyright law because of historical development. And important thing is that original copyright law makes monopolistic exclusive rights to who, usually these are organizations, not private persons, is allowed to make copies of something. But for open source license, they still rely on this copyright law, and they explain to these users who agree with this license that authorship of these copies is not exclusive but inclusive, or what they call it is reciprocal, or this means equal rights for everybody to copy. And that is important because if you, for example, hold physical book and, for example, somebody steals this physical book to you, then of course you don't have this book anymore. But if you have a book and somebody creates exact copy of this book, you didn't get poorer, you still have your book and somebody else have another book. And for example, Hollywood and music industry still call for their demagogic purposes and ideology that illegal copying is stealing, but stealing of course is quite different from copying, because if somebody copies my bicycle, I have a bicycle, and this maybe illegal owner of copy also has a bicycle. So that's important thing is that it still relies on copyright law, but all these open source licenses says that the ownership of rights to control copies is not exclusive, but it is shared. So everybody has more or less equal rights to make copies. And all the programs start with source code, and that's why copyright law is applied to software as well, because software also starts as a written text, so looks like a book to me. And it is in more or less human readable form, and then in most of cases you have to compile it, or you have to convert it to object code. Object code is like can be called binary code or executable. That is that form which is actually executed and understood by computers, not human readable, and it is derivative work of source code, but still it is just different copy of source code, because all this algorithm and information and knowledge what you wrote in source code of course is in this object form as well. And when we talk about open source software, because mimicry works also in technology, not only in biology, because of that open source software becomes so popular, you may see word open abused even in projects which are not very open at all, and you may see free in things which are not about freedom but are about something else. And you should know that so-called freeware or shareware is mostly not open source software, because if that would be, you could easily get out that part of code which do not allow you to use the software in any way you like, and particularly for like shareware, which limits usage to particular term. It can't be free, libre, open source software by definition, because it limits your rights to use this software for infinite time. And if that would be open source software, you can just get rid of that code which adds limits of time how much you can use it. And then of course there is public domain software. Every intellectual so-called property or information sooner or later gets into public domain, particularly for copyright. That is 70 or 75 years after death of author, because of lobbyism from publishing industry. They try actually to make this approach that these are 75 years for particularly made copy. For example, you make your own record of Mozart's waltz or whatever, music, which music itself or notes and sheet of notes is public domain, but when you make your particular implementation and record of that, they try to fight their rights, that they still have these exclusive rights to control copies of this record, because that's their creation. I think it is just derivative work. So here there is of course blurry, muddy area of tiesāšanās business about legal issues here, but if software becomes public domain, then if you ignore the thing what copy is and what derivative work is, then in general you can use it in any way you like. And thing about public domain is that there is no agreements between independent countries or states how public domain is actually considered. So there are differences in different countries, and therefore sometimes it is recommended to release your software as a open source software, not just put it into public domain, because public domain is less guarded by laws than open source software. But I don't know, I have not used software which is released in public domain yet, I think. And now about types of open source software. First, of course, there is proprietary or closed source license. I recommend to call it closed source. Proprietary means that there is one proprietary owner of it. But if you look on technologies, then this litmus paper is open source or closed source. And open source is considered open source only if it is accepted by Free Software Foundation or Open Systems Initiative. Everything else is just mimicry and smoke and mirrors. And so the most closed one is closed source software, and to make it work you have to accept end user license agreement, otherwise copyright law is not applicable to software in such way that you can install it but can't install it on another computer, and you can put it on hard disk but can't execute in random access memory or whatever. So therefore, if you can put closed source software without accepting end user license agreements, then you are fine. I'm not recommending it, but that's how it works from legal perspective. Then there is this free libre open source software, more or less open in terms of obligations to developers and distributors. All are open in terms of users. You can make copies, use it in whatever way you like on public domain. And in particular cases, what is important about licenses are so-called virulent or copyleft licenses versus non-virulent. Where is difference? Difference is here, what are your obligations if you make modifications in source code and if you redistribute your own copy of changed software. For these, which are copyleft or virulent licenses, there is one obligation to modified source code, that your derivative work should be redistributed with absolutely the same initial license. And that is obligation, so in theory you have less freedoms, but in general history has taught us that it is a good thing. And most prominent license for this is GNU public license, and Linux kernel is redistributed with this license, and it has different versions. Each next version has a little bit more obligations in terms of vendors and providers. And many years ago it was called like cancer, according to CEO of Microsoft Steve Ballmer, because everything which you add to this license should become software distributed with this license. And it is limits for some ways how large companies may monetize such software, and because of that later so-called lightweight or library lesser general public license was introduced, which is GPL license if you change original source code, but without this copyleft cancer-like spread if you include it in your project as already compiled library. And because of that, LGPL is also quite widely used. And so what are problems with GPL? First, if you have to link many projects together and to be legally correct, your project also should be GPL. And that of course is a big drawback for large companies who want to monetize these projects. Other thing is quite old. It doesn't talk much about patents, doesn't talk much about trademarks and other things. But important thing is, and particularly for GPL, it is GPL if you want to modify original source code, and non-GPL or not virulent copyleft approach if you just include this library as is without any modifications. And then there is other style of licenses which are not cancer-like, and most prominent and oldest one is BSD license. And BSD was license created for original BSD Unix, which was developed in Bell Labs 50 years ago. And it doesn't have any obligations for these who make modifications and redistribute this software with their modifications. And in terms of freedoms, it actually is more free because you have less obligations. But because of that, this software is much more abused. And as effect of this license is at first, there is only one Linux kernel. You may recompile it with many modules included, etc. But there is only one large Linux kernel project. But for BSD, there are many competing forks like FreeBSD, NetBSD, OpenBSD. BSD was used initially for Microsoft Windows to implement TCP/IP protocol, and of course BSD is used as a main part of iOS and macOS operating systems. But because it doesn't have this virulent approach about derivative works, requirement about derivative works, these companies like Apple can very simply abuse these projects, so open source comes into them, but closed source comes out, and they are legally fine. And even though BSD Unix is 50 years old, a little bit more, and Linux is only, let's say, 25 years old, Linux as a kernel has developed in much more rapid speed than BSD Unix because of this obligation and requirement that all derivative works have to be published with the license, which means publishing source code as well. And when you change this or that license as author of your software, remember about this. If you want to get contributions back, your license should be like GPL, like GPL version 3, which also talks about providing software as a service, because then everybody who makes modification have legal obligation to show their source code and redistribute their object code in the same manner as your original source code. If you just want to get market share, even if your software is abused, you use something like BSD license, similar licenses are MIT license, Apache license, artistic license, where you may get widespread usage, but you will not get anything back, because if it's not required, probably nobody will do this. And so later versions of BSD is like MPL license for Mozilla founded and managed projects. And currently there are approximately more than 50 open source licenses which are accepted as open source or free libre open source software licenses, either by SFS or OSI or both. And then there are many licenses like Microsoft Shared Code, which is not accepted as open source license because it allows you to see source code, but do not allow you to compile project by yourself and use your compiled version by yourself. So, and other licenses which may mention word open inside them, but which is actually not open or free to use as other open source licenses. And the idea here is that you shouldn't invent your own open source license, because there are good licenses already, which are tested by lawyers, tested by projects in real life, how it works, and therefore you should just decide, do you want to have obligations for these who modify source code or not, and some other things. And if we look on not so old study which licenses are used, you see that mostly these non-virulent licenses are used, like Apache, MIT, but also there are GPL version 3, which is very strict about contribution and giving back, GPL version 2, and other licenses as well. And what are benefits? First, you can get much bigger user base, because users can easily use open source software. And also, open source projects has been proved to be, maybe in some zombie state, almost dead, but never entirely dead, because from legal perspective, anybody can pick up this project, create his or her own copy of this project and continue work on it. So that is very important, because some of closed source projects have actually been died because original owner of software, like company, become bankrupt, and nobody is legally allowed to continue work on this code, and then usually just reverse engineered, completely rewritten projects become as a completely new implementation of same old ideas. And so other things as well. What are some legal risks? First, if you use some open source software which are licensed with some older licenses like GPL version 2 or BSD, older versions of software, you may involuntarily do something illegal in terms of patented things, in terms of trademarks and other things, and so some unexpected things may come to you. It was much more issue like 20 years ago, particularly, for example, for MP3 files and GPG files and some other things. It is not so big risk anymore, but if you are using software with some modern licenses which also adds clause about these other intellectual properties, then you are in quite strong ground. And then if you want to do some modifications, you need to care about requirements. What are your obligations for modified source code? You should know that some licenses requires you, called these virulent licenses or copyleft licenses, that all your modifications and derivative works also should be published as open source software. Then, of course, still all obligations regarding to trademarks apply, and consumer protection laws, etc. What is important is that if you are only owner of particular software, you may make it closed source any time you want. Only thing is that of course you can't revoke it retrospectively. If somebody will still like your project, they can continue your own fork of original project, even though you continue to develop it as a closed source. Such things are happened because some of companies use open source just like as a marketing approach, For example, they start with some open source solution, usually it is without these virulent features, and they use so-called open core model, that most of part of project is open source, some is closed source, but then gradually part which is open becomes smaller and smaller, and part which is closed becomes larger and larger, and then of course you can force your users to pay more royalties for that, etc. Typical example is, let's say, IntelliJ IDEA development environment. But so one of these things is how you can get money from open source project is start it open, and then if your license is chosen right, like non-virulent license, you can close it later and then force your users to pay more. But if you believe in ideas coming from Richard Stallman, that you have moral obligation to provide source code because users should know what they are actually using, then most of companies who still use real open source model, they provide services. And typical variant here could be like WordPress content management system. It's fully open source. Everybody can use it if they can host it somewhere and run by themselves, or you pay money, like few dollars in a month, to company behind. Actually, there are many companies behind hosting services for WordPress content management system. Other thing is like support, technical support, and like hosting and support, training, customization, integration, certification. Particularly, that's how initially some microsystems, now Oracle, gets paid by Java programming language, because Java programming language is royalty free. Everybody can write either virtual machine implementing Java or compiler compiling Java, but to get certification from Oracle that it actually conforms Java standards, which version, whatever, Java 8 or 18, then you have to pay for this certification coming from Oracle. So to create either virtual machine or Java compiler certified by Oracle, you have to pay them for testing and other things. And I think that is a more proper approach, because as Eric Raymond wrote in one of his essays, either I think it was in Magic Cloud Run, that software is largely a service industry operating under persistent but unfounded delusion that it is a manufacturing industry. And later, these ideas were extended to other information as well, and there is a term called open content. For example, different kind of artistic items and information like OpenStreetMap, etc., that similarly to open source software, you are allowed to make copies of particular item of information. And most prominent one for content is license called Creative Commons license, which is not very open. For example, if it has limitation about non-derivative works, which may be important for some artists who do not want to make parodies or plagiates about their work, but idea is very similar, that it's based on ancient copyright law, but again it gives everybody equal permissions besides author, that they can make copies of this work with some limits. Usually it is very frequent that you have to attribute original author from where you got this copy. This is something like virulent licenses and copyleft license for open source software, that if you make derivative work, it should be redistributed with the same original license. non-commercial, it is actually not compatible with open source software, because open source software allow you to use in any way, and they do not control. It doesn't mean that you cannot sell services or copies, but there is no legal limits to do so. But in this license it is allowed. And here some incompatibilities may happen, because if something is distributed with share like a non-commercial license, you cannot it easily mix together with GPL software, because GPL software says that you can use it in any way, but here you have limits that only for non-commercial work it can be used. So that's also you need to remember, that for virulent licenses you have some legal duties how you mix and pack different kind of information together. And similarly, there are other licenses with open content materials, like open content license, free art license, open game license, etc. So that's about alchemy versus modern chemistry. And if you are curious about this, here will be more informations, links provided when I will upload this presentation file. Any questions or comments so far? So then, in second part of today's session is topic called software evolution. Our idea is to tell about evolution of the software, how this looks like and how to manage it, how software evolves during time, and what problems does it have during maintenance and management in general. So, just a reminder that when you look on hardware, sooner or later it wears out and it breaks more frequently than after some time, when some issues and bugs were ironed out in early life of hardware. In theory, in software, all these numbers of failures should go down, because it doesn't wear out, and all the bugs which are fixed and made workarounds or whatever, in theory should make software better and better and better. In practical case it is not so, because of either internal changes when new releases of software are released, or because of external changes, because of external dependencies, what I talked about earlier, suddenly changes, and then many things may not work anymore as it is worked. And because without any changes, particular software may become more and more irrelevant, more and more out of sync with this external environment in its dependencies, usually what actually happens is that sooner or later also numbers of issues with old software grows up, but from different reasons. It doesn't wear out, but it becomes more and more hard to use, more and more irrelevant and outdated for all other environments where it is working in. And that's a problem, because sooner or later for any software what you are using, you may come to this period of time when number of different kind of issues pile up, and using it and maintaining it becomes harder and harder. And sometimes, of course, you use quite outdated systems, even maintaining it is nightmare. First, because any complicated system is expensive system. Much of resources were already put into it just to get it ready. And then there are different kind of dependencies on how business is run around this software, because business influences software and software influences how actual business is run for a particular organization. And many organizations or entire organization, if it's single large one, depends on this software. And you also need to remember that software usage is very labor intensive in terms of training and learning. Many users have trained to do this, many users have learned how to do this, and retraining them, of course, is also a very expensive process. And rebuilding systems is also high risk. If you try to rebuild systems from scratch, like you have learned your thing and now you will do it right, usually these projects tend to be even more unsuccessful than most of IT projects. And therefore, what is actually happened is that users usually stick to particular software for quite long time. Usual business cycle for different kind of enterprise level system is at least 7 years, and it is not very uncommon that it is 15 years or more. And of course, if you look how hardware has changed for 15 years and how operating systems, which are usually foundation of different kind of applications, have evolved, these have been changed quite a lot. And regarding to how systems evolve, there have made different kind of studies. One of empirical studies were done by guys called Lehman and Beladi, and they came up with so-called laws. And these laws are not actual laws like physical laws, but like Moore's law. Moore's law is also called law, but it is just an observation which sooner or later will not hold anymore. It doesn't hold anymore for CPU frequencies, because CPU frequencies have ended around 3-4 gigahertz already because of physical limits. And of course, number of transistors also will be limited pretty soon. But if you look on these observations and try to apply, there are still some of similarities occur which you can assume as a simplified laws. And what are these things? That first, change acceptance is dependent on how maintainable system is. If system is easy to maintain, it changes more rapidly, so it becomes modernized easier. If maintainability of system is bad, then it is changed very slowly and it becomes more and more obsolete. And costs also depend on maintainability of system, because if it's easy to maintain, then of course you can change it, and so if it costs less, you can afford more. And you should be able to predict how easy and how costly maintenance of software will be, because otherwise you may get into very unfortunate place when you will deliver first release, first public version of your software. First you need to predict how costly it will be to maintain. So that's one of the things you need to do some calculations how much it will cost to run. Then you need to be able to calculate how much this system will change and how much these changes will cost. And to understand how much system will change, first of course you need to understand which part of business this system is supporting and automating and solving. And there are more established businesses like finances and logistics, and some more rapid things like which are on the leading edge of technologies, I do not know. Public signatures and token exchange and like digital currencies particularly. And things what influences changes of system is how dependent it is on other systems, for example, how complicated and how many your system has interfaces with other systems and with users particularly, like users are one kind of interfaces. How frequently different kind of requirements changes, and one of the things you'll need to remember is that sometimes changes come from legislation. For example, for some companies which didn't care much about privacy of user data and the possibility to control who use what about particular private user data, when GDPR was introduced in European Union, they had quite a lot of headaches because since then they did many things illegally. Of course, if you cared more about control and privacy of user data before that, that particular change in legislation didn't affect you very much. And then, of course, there are different kind of businesses which changes more slowly or more rapidly. And these changes also influences how software changes, and changes in software are inevitable. It is just a part of life. Because business environment changes, because errors can be found and are found and need to be repaired, because hardware is changing, and because sometimes performance and reliability of system have to be improved, because when you start using some large enterprise system, initially you have small amount of data, everything works just fine, but when you collect more and more data, you see that some parts are not up to requirements anymore, because some parts are implemented badly and they cannot deal with larger amount of data anymore. And of course, other systems also changes in particular organization. So you need to fix different kind of faults, you need to adapt to external changes coming from hardware and your dependencies, you need to modify functionality of system, and you need to improve performance of a software if it was not properly implemented on first time. So particularly for business, I think I told, so legislation, new areas of market and new insights, efficiency. Yeah, organizations may be reorganized, you may need to merge some data coming from different organizations, you may need to split some data when organizations are split in parts. You may want to follow different kind of market hypes and also different kind of technologies, like more and more widely used internet and mobile platforms and other things. And from another perspective, you can look on these things, how you maintain your software, how you transform your software, and how you redesign it. So, and Evolution is very important because otherwise you will get more and more outdated software. And depending on how exactly you develop your software, it may be linear approach like a waterfall model. You first develop it, then you evolve it, and then you deploy it in production, and then you just service it. But then either you retire it or you start new cycle here again. And if you officially work with different kind of iterations, then of course you know that each part of particular release is just yet another iteration in terms of longer perspective how you develop your software. And important part about system is either phasing out this software and replacing with something else or implementing new version. When I have worked as a freelancer and also in Oxygen, important part of a large complicated project is to change one existing system to some more modern system. Why it happens? It happens because some previous system was not maintained and evolved and changed properly, so it became too outdated for business needs, and sooner or later some of owners of this software, users, if you use closed source software, you do not own it, you just use it, decide to switch from one kind of software to different kind of software. And sometimes it is very important part because it is tricky, because almost all the time you also need to migrate data from older system to newer system. For open source systems, usually they have pretty good tools to import, export data from and to similar systems. For closed source systems it is much harder because closed source systems allow you to import data into them, because then you get into their golden cage, but they do not allow you to export this data out of them, because then you will be able to escape from this golden cage. And that may be very critical part of supporting particular business, switching from one system to another. And particularly if you decide to still upgrade and evolve existing system, is that you get some new system which becomes old system sooner or later, but then you need to identify different kind of needed changes, and if you do this analysis according to different standards, sometimes it's called gap analysis. So you are here but you want to be there, and there is gap between here and there, and then to propose different kind of changes for the system, and then you do go through this software evolution process, and in details I will tell here. So how these change requests are done. First you need to do impact analysis, because even with good intentions you may break things and it will cost you something, and if you break something and it costs to you, then maybe it shouldn't be done at all. And then you decide how you will make these changes, how you will release these changes, either as new version or update or something else. Then you implement it, and then you make new release of the system, and then you go through this process again. And it becomes much harder as soon as you have real users with real data collected about the system, because you always need to maintain upgrade of data structures of your databases and other persistent storage when your system is changed. And you try to automate these things, because then you are much more sure that it will be done properly. And when you implement these changes, again you do analysis of these proposed changes, you update requirements if it's needed, and then you implement them. And particularly for implementing of changes, what is important is that speed, how these changes may be implemented, is different. What you should avoid, not at all costs, but as much as possible, is urgent change requests. So that means fighting fire. So something comes up and you need to fix something very rapidly, because this is high-risk business, because by dealing with one particular change and one particular issue, you may fix that, but you may break something else if you have not done testing properly, evaluation and other things properly. So therefore you always need to plan for these things to minimize these urgent change requests as much as possible. But if such things happen, you still need to analyze it, how it will affect your source code. And here, of course, from source code comes all these things about data structures and handling, etc. Then you modify it, and then you deliver it. And ways of delivering are different. If you have automated things, you may also deploy it to production automatically. If not, then of course it's more or less manual work, which is much more error prone. But the proper way to do changes is to do it gradually with much less risk to break something existing. So you prepare for future changes already and you implement them on that speed, how you can do it reliably and predictably. So that is this normal maintenance process. You fix different kind of errors found in production, and you will always find more bugs in production than in different stages of testing, because production is more complicated and there you have more data, you have more different kind of usage, etc. Then you need to plan for adoptions of environment changes, and also you may introduce different kind of functionalities. Particularly in Netcracker, where I work, for example, fault repairs are whispered. You always need to identify these changes with unique identifier. For example, fault repair is bugfix / blah blah blah, its unique number. But for functionality addition, it is feature / blah blah blah, unique identifier. So you see where it comes from, either from your bug fixes, and actually it has a little bit different workflow because of that, how it is changed. And then particularly for costs, usually what happens is that the development costs are smaller than total maintenance costs and evolution costs of the software. If you do more planned approach like waterfall model, then sometimes, and you do unique solution for unique client, then these costs may be comparable, like 50% of total costs for development, 50% for maintenance and evolution. But if the software is more standardized, and if you do more rapid approach in terms of delivery of software, like work in iteration, then usually these costs are much more. And in projects where I have worked as a freelancer, maintenance costs are always higher than development costs, because when I worked with different kind of local government institution, you have to support this software at least for 7 years. You develop something in 3 months, in half a year, deploy it, but then these 7 or 10 years actually makes more money in terms of your efforts and more costs for your customer than initial things. And therefore you shouldn't neglect maintenance and evolution. So, program maintenance work is unpopular, especially between developers, because developers are excited about new things, about new features, but maintenance is mostly about bug fixes. But if you do maintain and evolve software during maintenance, then of course you have both parts of them. You still need to do bug fixes, but you also introduce new features on that version of software where you are fixing different kind of bugs. And so maintenance costs are usually either comparable with development costs or greater, and sometimes much more greater than development costs. Especially if you use open source software, your initial costs may be 0, you can deploy it very easily, but your real costs are actually starting only when you need to maintain it. And usually, if more and more outdated your software becomes, gradually these costs creep up. So everything tends to become more and more costly, similarly to inflation in other things. It also is true for maintaining software. And here is one of use case, particularly for projects, that in most of cases, if you evolve your system properly, so when you start maintaining it, you still introduce new features, then probably adding new functionality is still biggest part of your costs. But then, of course, are bug fixes and adaptation to different kind of external changes. And costs also are influenced by how stable your development and maintenance team is, what are your responsibility in terms of legal contracts, what skills you have, and what is structure and age. So, in short, these observations about these laws is that software always changes, that software, when it's used, its complexity always increases, because in most of times you are forced and need to add things, and you add much more than you remove things and simplify. If you will look on one particular place of implementation, you may see gradually that the implementation becomes more and more efficient, faster, less code, less memory consumption, etc., etc. But these gains of efficiency in particular part of software cannot keep up with added complexity, with new models, new features, etc. And so this evolution depends on how large program is, how stable is organization or main user of it. It also depends on how familiar this system is. If system is very complicated and hard to learn, hard to use, then users will try to stick with this as much as possible. It depends on also how quickly you add new features, how it is growing, how it declines quality, because if you always will just add new features and never will fix any bugs, then of course your system will have more and more bugs and will be less and less reliable, stable, usable, etc. And of course it depends on feedback from user. And these observations, what they have found out, usually applies to very large, complicated systems, which are called enterprise-level systems. And sometimes it is still, these rules are applied. For example, when you need to make your proposal for developed software, you may need to say that, for example, if development is like 100 units of something, then maintenance cannot be more than 500 units of something, either thousands or tens of thousands or millions or whatever. And that is one of these cases of this rule applied about observation, what is distribution between like development cost and maintenance cost. Or if you, for example, implement commercial closed source of the shelf software, for example, if initial implementation costs you 10 units of something, then your license cost usually is 1/5 of initial costs per year, something like this. And these costs also depends on how complicated your system is, what are complexity of control structures or source code, what complexity of data structures or your different kind of storage, and what are other metrics of complexity of your software. And because in most of cases any software which is still living thing becomes more and more complicated, then all these costs also becomes bigger and bigger during time. Also, particularly for closed source and legacy system, is that when you do system integration, there are things and places where it's easy to integrate with different things and where it's hard. And then, of course, if you have done very tricky integration between different kind of closed source systems, changing one part of system is much more tricky, so it becomes much more costly. And such older inherited systems may be called legacy systems. In general, legacy system is system which is not very well understood. If you already implement system which is poorly documented, poorly understood, and hard to use and learn, it is legacy system from its beginning. If you provide a little bit better quality for documentation, for maintenance and training, then initially it is new system and it gradually becomes legacy system after some time, when your documentation gets outdated, when your training courses become outdated and other things. And so sooner or later different kind of organizations need to deal with these legacy systems. And then they may need to decide what to do with such systems. And one approach is to analyze these systems in terms of their quality and in terms of their business value. If some legacy system is high quality and with high business value, of course you do not throw it out. You try to maintain and evolve it as much as possible. And complete opposite, if system quality is very low, business value is very low, then you will need to throw it out and replace with something better if you want replacement or just don't use it anymore. And then somewhere in between are these cases when high business value but low quality, or low business value but high quality. It depends on your priorities between business value of the system and also quality of it, how it's easy to use, etc. So for these legacy systems, these which are low quality, low business value should be scrapped. No question, high quality, high business value should be continued to maintain and evolve. And particularly, for example, high quality, low business value, try to replace these free libre open source software or commercial off-the-shelf software. So that means instead of some unique solution, try to replace it with some standardized solution which will be much easier to maintain and use. And for low quality, high business value, here you may think about re-engineering it and replacing with something better, because sooner or later you may get into trouble. And how you assess business value, you check what end users think about it, what business customers think about it, line managers, like this means these who are responsible for production of services provided by the system, different kind of managers, lower level, higher level, etc. And of course you may collect data with anybody else who is involved in this system. And what is kind of business value? First, what process of your organization this system supports. If it's your core process, of course it is very high value. If it's some support level process, then it's not so important, because different kind of support processes may be changed if necessary. And of course you check how dependable this system is, how reliable, how secure, etc. it is, and what kind of outputs it provides. For bureaucratic systems, sometimes they tend to be black holes. You put information in, but nothing comes out. And even though these users who put information into this system might prize this system as easy to use and high quality, etc., you need to remember that any system which takes some information in also should provide some information out. Otherwise it is just for bureaucratical purposes, just to fight just another kind of bullshit job. And then when you assess its quality, you need to check what kind of process is around this system. Is this process sane? Is it efficient? And can it be changed to something else or not? What is environment around it, and how exactly it is used? Because sometimes you have very large, very complicated system like Microsoft Word, but then you use only 1/10, 1/50 part of all this complexity. And of course it comes to you for free. Maintenance is easy, so what? But if it doesn't come to you for free and maintenance is hard, then you should think about switching to some simpler systems. And particularly for business process, what is also important. So you just need to do this analysis similarly as how you did analysis for newly developed system. Sometimes you do regularly, and regularity may be once a year, once in many years. You need to review your existing system, how do you use them, how do they work, and what value do they provide. An important part here is how stable is service provider. For example, is it still in business? Is it reliable? How you actually relied on it? Because sometimes excuse for commercial off-the-shelf closed source software is that somebody will provide you service for bug fixes, etc., but then you pay this large amount of royalties to use this software, and then you actually do not use their services at all. So you just spend this money for nothing. Then you need to check how frequently you had different kind of failures and what were the cause or reasons for these failures, how old this software is, how well it is performing, are you satisfied with this performance, how well it supports your requirements. Maybe you have a very large gap between what you want and what this software actually provides. What are maintenance costs, including royalty payments for closed source software, and how well it integrates with some other systems used by your organization, by other organizations which are your involved parties. Then you check, for example, how well you understand this application. Of course, rating for closed source application here will be much lower than for open source applications. How well it is documented. Do you understand internal data structures, how it actually works? For example, many large enterprise systems have relational storage as a backend to store data. Do you understand this internal schema by yourself, or is it just one very large mess, and only way how can you deal with these data are through provided software? Then programming languages. Sometimes programming languages becomes outdated. You maybe need to switch to something else. How it's easy to maintain configuration, that everything is properly configured for it to work. Do you have test data, and do you have skilled personnel to actually maintain it? And when you measure these things, one of input metrics is, for example, how frequently you have different kind of change requests. And of course, important part here are these urgent change requests when you need to fix something very quickly. Then how different interfaces you have, particularly user interface, and what kind of volume of data you have. And then you may need to decide about software re-engineering. So what is re-engineering? Re-engineering means reconstructing some part or entire software a little bit differently. Software engineering was very popular in around year 2000 because many of information systems used then were around business without internet. So everything was just local area network. Everything else was divided by paper and these things. But then around year 2000, more and more businesses introduced information exchange through the internet, so many things were re-engineered to do it a little bit differently. Now it is not so high wave anymore, but still you need to re-engineer systems, for example, for different kind of mobile devices. You may switch from real computers like desktops and laptops to mobile phones and tablets and other things. And so you still may need to change something because life changes. And re-engineering is in general considered a better and less risky approach than writing new software completely from scratch, because you may introduce changes more gradually and you may test and try things more gradually with lesser risk than writing something completely new, because all complicated software starts with ideal things that no, we will do it right, but sooner or later every large complicated project ends up with large mess, and in short, large mess of system means that nobody understands the entire system, and any more complicated system is not completely understood by anybody, so everybody involved would think that it is just large mess, that if it would be introduced from scratch it would be simpler, but actually it is not the case. And also because of less risky approach, easier to things to try and test out, usually re-engineering existing system is actually cheaper than doing it completely from scratch. And here about engineering, two different approaches can be used. Forward engineering is like how you develop new system from scratch. You start, if you use this planned linear approach, you start with high level business goals, then you create requirements, specification, and implementation. But if you already have legacy system, then you can do it in different approach. You may do either reverse engineering, for example, if it was some closed source approach system and you want to switch to newly created open source approach, then fortunately to us, ideas cannot be patented and copyrighted. Only particular, let's say, documentation of them can be patented and copyrighted. So you may get some existing system, and from existing system of implementation you can specify it, create requirements and goals, and then create either something completely new from scratch, or you just do gradually some kind of re-implementations. So in general, reverse engineering means you have something existing and you do it backwards from actual thing. You do specification of design, requirements, and initial goals may be changed from existing thing, and then you either do forward engineering for completely new system, or you still may do reverse engineering and re-engineering for some parts of system. And of course, if it's open source system, you are completely allowed to do re-engineering of existing system to satisfy your needs. And of course, real life is messy. You all the time, sometimes you go from high level goals to implementation, so you do forward engineering and sometimes you do reverse engineering. So that's how you do system re-engineering, either reverse engineering or restructured engineering, and you make software hopefully better, at least different. And in re-engineering, what can you do? For example, if a programming language is outdated, like you want to rewrite old school software written in, I do not know, Pascal or Fortran or whatever, you want just to translate source code to different programming language. There are different kind of tools called transpilers, which take source code in and puts source code out, but in different programming language. And you may try to do so-called heavy lifting in such way, and then nothing is ideal. Of course, you will need to fix different kind of parts of code manually by yourself. Or you do reverse engineering, you analyze program to understand it, and then create probably completely new software from it. It's sometimes done for legal reasons, so-called clean room development, because of all these legal issues related with closed source program, with patents, trademarks, etc. You may do reverse engineering to document some existing software, and then from this documentation you completely re-implement it without any actual influence from original software to the new one. For example, that's how Google re-implemented Java for Android operating system. Mostly it was because they were not completely sure that they can use Java in Android as freely as they are doing now when they have their own Java implementation. That of course comes with a cost, because for other kind of computers, actual Java version is, I think, Java 18. Of course, still to Java 8 it was not changing version numbers so rapidly, and then it became more rapidly, but I think Android Java is still compatible with Java 8. So then you may improve different kind of program structures and data structures to understand it better and maintain it better. You may introduce modules like make different parts of systems more independent, or you can re-engineer only data, like restructure and clean up different kind of data structures, not actual behavior or source code. And so there is no hard split between different kind of approaches, but there is a gray area of different kind of approaches. How can you re-engineer it, starting with easiest one, like if you re-engineer it completely, like just rewrite it in different programming language with transpilers, then restructuring program, restructuring manually, data restructuring, and then completely rebuilding it like manually and using just documentation as an input. So you, for closed source software, you are not allowed to get source code, and you, of course, even if you get, for example, with decompilers, you are not allowed, for example, to use transpilers it to refactor this decompiled source code to different programming language. So then you need to describe everything as a specification, as a requirements, and then do it manually backwards into software. And costs, of course, here are greatly influenced by how automated your process is. As more automation is possible, as less risky and cheaper it is, and as more manual labor is needed, as more costly and more risky it will be in short times. And when you do such refactoring, it may be called as preventive maintenance. Preventive maintenance means for hardware that you replace some parts of hardware even though it works, but the risk that it will fail increases, and maybe not gradually, but like exponentially, because of wear out and other hardware related issues. And similarly with software, everything still may be working, but if you look on future and try to count these costs, you may see that actually preventive refactoring may be cheaper than dealing with all these maintenance issues later. And that's about refactoring. And remember that there is gray area between different kind of replacements and evolvements of a system. Complete re-engineering or rewriting something completely from scratch is extreme end of preventive maintenance, but usually you may do less risky approach, more gradual approach, that instead of rewriting everything completely from scratch in different programming language or different environment, etc., you gradually re-engineer some parts of software gradually, either switch programming language gradually or switch environment gradually, etc., etc. And so such a gradual process is always less risky in long term and always cheaper in long term, even though initially it may look like that complete revolution may be cheaper. So similarly as in society, evolution is always better than revolution because it's more gradual and less risky and therefore more productive. And what are key points? Key points are that changes are inevitable and you need to plan for them, and you need to understand what external factors and internal factors in your organization will influence them. So you need to anticipate, will you have many changes or small changes during software maintenance or not? for these custom systems which are developed for unique customer, for unique business process, usually maintenance is more costly than initial development costs, even though development costs also may be high. And these different kind of changes need to be analyzed, and you need to check, for example, what are impacts of these changes and how you plan and release them and how you change them. And you always need to make changes in planned manner, and you should avoid urgent changes as much as possible. I'm not saying avoid at any cost, because if you will avoid at any cost, then of course it will become more expensive. But you should avoid urgent changes as much as reasonable possible. And it's usually cheaper and less risky that you maintain legacy system and gradually develop and replace it than change something very completely. Of course, changing something very completely still may be good thing if you change from closed source software to open source software, because then many of risks involved with closed source software about maintaining it, about understanding it, about changing it is always much less risky in open source software than in closed source software. So I think that will it for today. Do you have any questions or comments?